Hi, welcome back. Let's try out these trigonometry questions. Question 3 reads, if cos of 23 is equal to the square root of 1 minus g squared, express each of the following in terms of g. A question like this will involve drawing a diagram. So let us construct a right angle triangle. Now we'll input 23 degrees. Now we can calculate this unknown angle using some angles in a triangle being 180. So 180 minus 90 minus 23, that's going to give me 67 degrees. Now cos of 23 is the square root of 1 minus g squared. Now we know that cos is equal to adjacent over hypotenuse. So this is going to be the square root of 1 minus g squared, and our hypotenuse will then be 1. We'll then need to work out this unknown. So let's work out the unknown using Pythagoras. Let's make it simple. Let's label this a, b, c. So we'll say that ab squared is equal to ac squared minus bc squared. That's Pythagoras. Now ab squared is going to equal ac is 1 squared minus bc is the square root of 1 minus g squared, all squared. Let's then simplify. ab squared is equal to 1 minus, now this square will cancel that square root, and then leaving us in brackets 1 minus g squared. We can then simplify. ab squared is equal to 1 minus 1 plus g squared. The 1 minus 1 goes away, so ab squared equals g squared. That means AB is equal to G. So this length is equal to G. Now we can work out sine of 23 degrees. Sine of 23, we know that sine is opposite over hypotenuse. So 3.1 sine of 23 degrees is going to equal G over 1, which we can then simplify as G. Question 3.2, tan of 113. Now there is no 113 on our diagram, but we can rewrite 113. So let's write, so tan of 113 degrees, that is equal to, let's see, so 180 minus 113, that's 67. So we can rewrite this as tan of 180 minus 67 degrees. We do have 67 on our triangle. Now we need to reduce this. How do we reduce it? Let's look at our cast diagram for a second. C A S T. So this quadrant is 180 minus theta. This quadrant is 180 plus theta. This quadrant is 360 minus theta. Now, if it's still not clear, what we can do is just replace this with 180 minus theta. Tan of 180 minus theta is minus tan theta, because we're talking about this quadrant and only sine is positive in that quadrant. So it's going to be negative tan of 67 degrees. So minus, and then tan of 67 is going to be the opposite over adjacent. Opposite of 67 is the square root of 1 minus g squared divided by g. We simplify. That's going to give us minus square root 1 minus g squared all over g. All right, let's solve the last one. So the last question says sine of minus 653 degrees. So question 3.3, sine of minus 653. So what do we do in this case? In this case, since the angle is greater than 360 or greater than minus 360, what we should do is we need to keep adding 360. So we'll do sine of minus 653 plus 360, and that gives us minus 653 plus 360, that's minus 293. So sine of minus 293. Since it's still negative, let's add 360 again. So plus 360. So plus 360, that gives us 67. So that's the same as saying sine of 67. Now we can do sine of 67. There's 67 on our triangle. So sine of 67 is opposite over hypotenuse. So that's going to equal, so sine of 67 degrees, that's equal to square root of 1 minus g squared over 1, which is simply the square root of 1 minus g squared. Okay, let's move on. So next question says, simplify the following without a calculator. Now again, we're going to use a cast diagram here. Let's draw in our cast diagram. So we got C, A, S, T. This quadrant is 360 minus theta. This quadrant is 180 plus theta. This one is 180 minus theta, and that's just normal, right? Then also, okay, that's fine. Let's look at question 4.1.1. So cos of 390. So 390 is the same as saying 360 plus 30. Okay? So this quadrant is, you could think of it as 360 plus theta. So cos of 390 can be rewritten as cos of 360 plus 30. Now 360 plus 30 is first quadrant. Now if it's not too clear, we can write that as 360 plus theta. So that will reduce to cos theta. So cos of 30 degrees. Next, we got cos of negative 30. So cos of negative 30 degrees. Now negative angles means a rotation clockwise. So negative theta or negative 30 will be somewhere here. Cos is positive in this quadrant. So cos of negative 30 is the same as saying cos of 30. Next, we have tan of 360 minus x. So tan of 360 minus x, let's write that out. So tan 360 minus x. 360 minus x is a fourth quadrant, and tan is negative, so that will reduce to minus tan of x. We then have cos of 180 plus x, running out of space here. Cos of 180 plus x. 180 plus x is third quadrant. Cos is negative in the third quadrant, so it's going to be minus cos x. And the last one is cos of x minus 90. Let me just write that here. So cos of x minus 90, let's rewrite that as minus 90 plus x. Actually, no, I think we can work with it as it is. I'll show you what we do here. So x minus 90. Now to solve that, let's do this. So we imagine our diagram like this. X is an acute angle, so x is somewhere here. And then negative 90 means clockwise rotation 90 degrees. So clockwise rotation 90 degrees, like so. That means we are sitting here in this quadrant where cos is positive. So we're going to have a positive value. And since it's a 90, if we have 90 or we have 270, then we change that from cos to sine. So this is going to be positive sine x. All right, so we have all our reductions. Let's put that into our original and then simplify. So cos of 390 we got is cos of 30. Let me use a different color. So cos of 30 and divided by cos of minus 30, we said is cos 30. Then minus tan x, and then multiplied by cos of 180 plus x, we said is minus cos x, and then we have times sine x. Now we know cos 30 divided by cos 30 is 1. So 1, then plus tan x times minus cos x times sine x. Now we can rewrite tan x. So 1 plus sine x divided by cos x multiplied by minus cos x multiplied by sine x. So this cos and that cos will cancel. We can then multiply the sine x times minus 1 times sine x. That's going to give us 1 minus sine squared x, which we can then reduce to cos squared x. That's our final answer. Okay, next one. Question 4.1.2, sine of 120 degrees. Okay, let's just neaten this up a bit. Okay, so let's do our reductions in this corner here. So sine of 120 is the same as saying sine of 180 minus 60. Sine of 180 minus 60, or sine of 180 minus theta, is this quadrant. Sine is positive there, so that's equal to sine of 60 degrees. Next we have tan of 330. So tan of 330 can be rewritten as tan of 360 minus 30. 360 minus means fourth quadrant. That means tan is negative. That will reduce to minus tan of 30 degrees. Then we have cos of 240 degrees. Cos of 240 is the same as saying cos, let's just simplify this. So 270 minus 240 is 30. So this is the same as cos of 270 degrees minus 30 degrees. Now cos of 270 minus 30, we can then reduce that. 270 minus 30, no, rather let's do this. We can have cos of 180 plus 60. So cos of 180 plus 60 is going to be third quadrant. We can then simplify, because cos will be negative in the third quadrant, we're going to get minus cos 60 degrees. Now these are special angles, and we can write out these special angles. Let's answer it now. So sine of 120 times tan of 330 divided by cos of 240. Okay, let's write it out. So sine of 60 times tan of 330 is the same as minus tan of 30 divided by minus cos of 60 degrees. We can then simplify that as sine of 60 is square root 3 over 2 multiplied by minus 1 over square root 3 divided by minus a half. Cos of 60 minus cos of 60 minus a half. So that negative and that negative will cancel. and we'll be left with an answer of 1. Yeah. Well, okay, let's simplify. So numerator, we're going to get square root 3, minus square root 3 over 2 square root 3. That's going to cancel with that. We're going to be left with minus a half divided by minus a half, which is 1. Okay. Let's move on. Question 4.2. Prove the following identity. Cos x times tan squared x divided by 1 over cos x plus 1 plus cos x equal 1. Okay, so question 4.2. Cos x times tan squared x. Let's rewrite that. So cos x times tan squared x can be rewritten as sine squared x divided by cos squared x. Then divided by 1 over cos x plus 1. Then plus cos x. Now this cos x and that cos x will cancel. We'll then be left with sine squared x divided by cos x divided by, let's simplify this. So we get an LCD. Now the LCD for that will be cos x. So we'll have 1 over cos x plus cos x over cos x. We can then join it. Let's do that now. So you will have 1 plus cos x divided by cos x, then plus cos x on the side here. Now let's deal with this fraction. We can tip and times, I guess. So we'll have sine squared x divided by cos x, then divided by 1 plus cos x divided by cos x. So we got that, and then we got the plus cos x on the side. Now when we tip and times, this is what we will be left with. Now since there's only cos x's in this bracket, right, I'm going to change sine squared x to 1 minus cos squared x, and divided by cos x, and times cos x over 1 plus cos x, and then we have the plus cos x here on the side. Now this cos x cancel with this cos x, and then the 1 minus cos squared x I can write as 1 plus cos x and then 1 minus cos x, because that's the difference of two squares. I can then cancel this and this, leaving me with 1 minus cos x plus cos x, and that goes away, and then the answer is 1. So we've proved the left hand side equal to the right hand side. Okay, let's move on. Question 4.3. Given the expression cos 2x times tan x divided by sine squared x, determine the values of x in the interval x is the element of 0 to 180 for which the expression will be undefined. So it will be undefined. So tan x has asymptotes, and when the denominator is 0. So first one we'll deal with is tan. So we'll say when tan x is equal to 90 or 270. So those are the asymptotes for a normal tan graph. Since they're only looking between 0 and 180, we'll say that we'll reject this one. So that's not applicable. So one solution is 90. Then the second one is sine squared x. So when sine squared x, when my denominator is equal to 0, now we can't solve that. So what we'll do is we'll change this to dots. Right? So we'll say, what I mean is we'll say 1 minus cos squared x equals 0. Then we can do 1 minus cos x, and then 1 plus cos x is equal to 0. That means that cos x is equal to 1, or cos x is equal to minus 1. Then we can solve for x. We get x is equal to 0 or x is equal to 180. And so we got our solutions. So we got our solutions being 90, 0, and 180. So those three solutions will give us an undefined expression. Okay, let's move on. Question 4.4. Solve for a and b if. Now, what we can do here, we've been given this. So what we can do is let's deal with one at a time. So first one, we can solve for a plus b. That's going to equal cos minus 1 minus square root 2 over 2. That means a plus beta, or alpha plus beta, is going to equal, let's put this in the calculator, shift cos minus square root 2 over 2. That gives us 135 degrees. Next, we'll repeat for the other one. We'll say alpha, let's write it properly. So it's alpha minus 2 beta is equal to shift cos a half. That means alpha minus 2 beta is equal to 60 degrees. Now we can solve. What we can do here is we can transpose this beta there. That means alpha equals 135 minus beta. And the same thing here we can say is alpha equals 60 plus 2 beta. So we have equation 1, we have equation 2, we can equate them. So 1 equals 2, 135 minus beta equals 60 plus 2 beta. Then we can solve. We can say 135 minus 60, that's 75. So 75 is equal to 3 beta. That means beta is equal to 25 degrees. Now we know one value, we can work out the other. So if alpha plus beta is equal to 135, alpha plus 25 is equal to 135. That means alpha is equal to 135 minus 25, which is equal to 110. Okay, and that's it for this section. If you found it useful, please leave a like, share, subscribe, and don't forget to hit that bell icon. If you want something specific or more like this, please let me know in the comment section below, and I'll see you in the next one. Bye.